Hello everyone, welcome back. We are going to be picking up where we left off from our previous video. And to recap, in our previous video we successfully eliminated the support rods that were coming from here to here to here to here. So we eliminated this part of the rods that shouldn't be there because otherwise you won't be able to walk on the bridge. And also for the other side, so this is the start and we also did it for the other end. And this video we're going to be focused on specifically the rods on this part that is blocking our entrance to the viewing pods here. And after that, what we're going to do is duplicate this whole script that we made and apply it for the minor helices. And after that, we can focus on the bottom of the bridge to make the support for that. And if we still have time, we can look at or maybe start to explain how are we going to do all the interconnecting lines between the inner and the outer helices. Those are actually the most intricate ones that we have to pay attention to. Could be difficult to pull off, but we'll try. But first, let's focus on what we can do for now, which are removing these three on every viewing pod that you have. And the method we're going to be using is use a smart way to find which three of these are. Because we know we separated start and the beginning, and we have a middle section. We know they exist in the middle section. The question is, which one of them? There is a simple way to do this. We can use our viewing pod as the geometry that we use a viewing pod as a Boolean operation. And we've actually done that already, which I believe, yeah, we actually use it for our modification, because remember we want to use it. We used it to determine that point there on the top, so we can actually reuse it. So let me copy both of these and just gonna paste it here. So this is a Boolean geometry. And the next thing we're going to need is, if we go to intersection, we want to use a surface to line. The surface obviously goes to the L, of course, in the S. And so now what we want to do is, out of all these lines, we want each of them to test if they intersect with our Boolean geometry. Not just the ring, but every one of these single segments. So that would mean that we have to graph this, flatten this. And when we input this here, we have to graph the L input in order to make sure that every item here is going to be on its own branch, will be intersecting with all four. And I would expect to have 12 points of intersection because we have 4 parts and they intersect 3 times each. As you can see, if you hover on the P, you see just on the top, somewhere in the top, you see 12 locally defined values, meaning we have 12 data points. Now, what I want to do with this, I want to extract. If I put in a param view for you, maybe that's easy to see. What I want to extract is actually this number. I want that number. Obviously not this one, because this one is not intersecting, it's 0. I want the number where it says 1, because that's the one that it intersects. Let's clear that, make that out of the way. One way to easily come up with that is, let's simplify this. We have way too many trees that we don't need, so let's also clean the tree a bit. So we're going to put it at T. Remember to turn on remove empty branches. By default, this one is off. At least in Grasshopper, in my version, it's off. So now that we have that, we should have a very clean data structure. Actually, let's use the param view. That one is a bit more cleaner to visualize what we see. Good. But these are the numbering of branches that we need in order to find out which one of these they are. So what we can do now is say we want to extract these paths, so we can do a tree statistics onto, well, we don't really need the L per se, because the 0, 1, 2, 3 actually refers to which of these Boolean the Boolean geometry that we want to use. So we actually don't need those. One way to eliminate them is to use trim trees, and we only trim it by once in order to remove that. Now we can plug that into the tree statistics, which would give us a P, which stands for the paths, this one. And now the way we can use this information is by using a component that you should be familiar with because we used it once. I believe not here. Oh, it is here, which is the split tree. So if we use a split tree here, we can actually use this as our mask. But the data that we want to split will come from this, but it needs to be grafted. As you can see, we have 2 levels of branches, and this one only has 1. So if we plug this in here, remember to graft it once, so the data structure matches with this one. And you can plug this simply here. And let's move everything. And we only want the negative space. And there we go. We eliminated in a very simple step. And actually 1, 2, 3, 4, 5. And those helpers, we've managed to eliminate smartly and parametrically the ones that intersects with or that interferes with our entrance to the viewing part. And now what we can do is I actually want to rebuild this back to this format. So what I'm going to do is trim this tree once in order to get 1 level of trees, and I can actually now merge all these together. Oh, let's disable that. Let's move this a bit like this here, and now we have all our trees. Or actually now our support stat is exactly how it should be in the real bridge. Now you might want to go ahead and say, you know what, we have one item that is actually intersecting with a different item that we have. I mean, you can fix that, but since our main helix is already, it should be overlapping this one. If it bothers you, you can perhaps I think then you have to do something with this with our geometry. Either scale it to that way in order to remove it, or you just leave it at this because no, it doesn't matter what you do with it, it will be overshadowed, or it will be sitting within the tube of our major helix. So for me, that's not really a problem. So that's why I leave it there. And now let's give it a thickness. Let's give it a thickness, and let's get a thickness and a color. Oh, do I have the diameter of our tubes? No, I don't, obviously. So I'm gonna copy it from here, paste it. Let's leave it here, and drag it all the way to this R. And I'm gonna skip that in there. I mean, obviously, the supports are not in the same thickness. Let's give it a different color for now. Let's make it easily identified. Well, it's not red. Red's the minor helix, so we can maybe. Actually, I don't know what color to give it. Something a bit more light. That would be, let's say somewhere like soft. orange something. Maybe something like that. I don't know. Something like that. Or you can decide. Yeah, you can decide. But what I want to fix first is actually, let's put in a number here. Because we have to use this for the other ones too. We drag this here, and instead of dividing by 2, because diameter divided by 2 gives you radius, let's divide this by 5. How does that look? Uh-oh. How does that look? I would say that this is a lot better, but since this component is, well, it's not that heavy, but what heavy is actually my render viewport. I have it on render, that's why it's struggling slightly, but we'll leave it at this. So this is our, do I need to copy this? No, I don't think I need to copy. Okay, let's do it like this then. Let's do an entwine, a merge and then an entwine, and then let's say everything that goes here will be piped and giving that color. And then what we can do is actually disable this for now and then just see this because it's a lot easier to move. And now what we can do is copy, well, not all of it. Now we can move on to our minor helix. So let's go back and see what we've done. So we can see which one we need to copy and what to leave it as is. So we have our helices, the minor ones, and what we've done there is we cut off that and then we took the negative part, which makes sense, and then we applied it to all these that come from the I-beam, which is fine. This also comes from the I-beam, so maybe I can shift this slightly up. Let's shift this all slightly up because this can be reused, or at least it will be reused. So we can copy all this. We need to copy, do I need to copy the circle? I might need to copy the circle, but then it will not be this circle. It will be the circle for the minor helices. Okay, so I think I need that too. Photo bridge section, I don't need that because this one goes in there, this one goes in here, the rest goes from there. So actually, if I just drag, hold down Alt, release. There we go. You know what? I could have probably dragged this slightly bit more down, to make it a bit more visual for us. I don't know what. Oh, that's what he did. Okay. Let's see what we can do to clean this up a bit. Okay. So first things first, we need a circle, but we don't. Let's actually disable this one for now. We don't need the large circle. What we need is a circle that corresponds to our minor helices, and we've made that, I believe, also here somewhere. Helix points, inner circles. Oh, we have that already. Where do we have it? We have it here. We can copy that. So if once we didn't we copy that one here also? Apparently we remade it, so that's also fine. It comes from the same thing anyway. So we need to have this replace our circles, because we already have our circles, and this takes from a circle, so we can just copy that here. We can delete that. We have this. These are all our curves, I believe. Yes. So it will be the negative, because the positive is the one that we called away, which are that tiny bit here that we don't want to include. So we can take the n, put it there. What's this? What's the p? That's the planes that comes from where? That comes from there. Okay, that should be fine. What's this? These are the circles. So, oh, these are connected. These are P projection point. Where do they come from? They come from the S point from there. Okay, that's to move the seam of the circle into place. What we done here. So let's check that. Double sure. Point on curve, because maybe we want to rotate that and move the seam to the other side. Maybe we don't want it here, but we actually want it. Oh, we don't want it there, but we actually might want it on this side. So what we're gonna do is I might take the endpoints instead. That point exactly. Should I though? Should I just make a point? Actually, that would be better. Let's just make a point. So we can drag this down and put this here. One thing we do make sure is this helping parameter that we applied, I think that should be not minus, because we did a minus to make sure that it always starts just below our reference point. But now that this thing actually goes counterclockwise, what I want to do maybe is plus. I think we have a minus in this one. Exactly. So we do it plus. Circle is now defined. Something's wrong with this. Why? What's this? Oh, those are our negative points. Might take a while. There we go. What are these? These are curves. Actually, let's just turn on the end result and see what's up. And also, let's turn off our major helix and turn back on our minor helix. There we go. Okay. Let's see. Let's focus on the first bit, this bit. I can see that it's successfully divided into start and end, which we expect. Except for one thing though. Rods to be called. This one, this. This in the helices, yes, but actually, I want to move this down a bit. Section to call for major helix. I think I used two names here. I used major and outer. They represent both the same thing. One reason why I want to do this is, for example, let's plug this in. Where did it come from? It come from there. Okay, let's plug this in there. One thing we have to be look out for is that if I take a picture, one of my pictures back, remember that we counted a certain section, right, for all the imaginary ones that comes from here to be culled. But in the case of the minor helix, it's actually a lot less. If I can zoom in, probably that one. See that it starts here is when you have like the full support rods on that one. Oh, that one just got deleted. So the way we can sort of count this, perhaps, well, I can count it from this one actually. So this is one section, 2, 3, 4, 5, 6, 7, 8, 8. Oh, 8. Because if I can look at this actually goes there and goes here. So it skips 2 width between helices. And that works out great for us because we have here 3. We just need to change it to 2. And then result should be 8 because it skips 8 section. And that also minimizes our size for this. One thing I think we should do is, because now we flip to the other side, we might have to reverse the culling. So I think if we reverse that, we get the ones that we need, and we need to unreverse the other end because the other end is doing the exact opposite. So if I unreverse this, I get the ones that I need. And now people can actually walk through without these stainless steel beams hitting your face. Okay, with that gone, we can focus on the middle part. I think the middle part already fixed itself. I'm not sure. Let's see. Yeah, see, it did. It it fixed itself because the algorithm that we defined is the same. It doesn't matter where they are. It will always find the ones that intersect and call that away. If you don't believe me, you can just turn on the split mask. The split mask should return 12 on the P, which are the 12 points or the 12 lines that intersect. So with just that, we have the minor helix fixed. And we can, should we move this up a bit? Or should we not move this up at all? They all come for the same thing though. Difficult. I might want to sort this out a little bit just to make it a bit neat. Clean this up a bit. Do I need to have this here? No. I actually have this here along with all the global sort of parameters up used by everyone else anyway. Oh, this is the helix sorting, which for me is this one. So what I can do is actually move this slightly up there. Pull this down a bit. It was pulled up just for visually clarity, so I can see better. And then, what's that? Oh, that's the radius. Now I can connect it here into the entwine. Can remove this. I can. Actually, don't want to enable that. It might crash. But if I re-enable our major helix, you know what? Let's just do it. Let's just do it and see how it looks like that thus far. Piping using the normal pipe of Grasshopper always takes a longer time. So, but if you just want to purely visualize it, I recommend you download and use Mesh Pipe. Mesh Pipe. That one is a lot faster, like insane. But in terms of accuracy and color, of course it's a mesh, so you either have to increase the density of your mesh, especially if it's section here somewhere, number here. But it's a lot faster. I don't remember where I got it, but if you just go to the Food for Rhino website and look for mesh pipe, you will find this one. But anyway, so this is what it looks like thus far, and I'm gonna disable that, so I don't wanna, so I can move a bit more freely. And now we can actually focus on the bottom part. Now, if you remember correctly, we actually separated the bottom part using, where was it? Using a dispatch, I believe. Yeah, this one. So we just now need to combine the B and the A, and then we should have it also. So let's actually make room for the middle part in the middle, which to me makes more sense. So I'm gonna take all these, slightly back down again a little bit, and then what I'm gonna do is I'm just gonna create a CRV and take out the B's, and then I'm gonna name this bottom. Oh, I'm gonna name this bottom outer helices. Copy that name, copy that, and take another B from the minor, and this will be called inner. There we go. Now we have the two nice bottoms. Okay. The same procedure goes for the rest. We just, well, we split them using a curve. Oh, we also need to include, of course, the top one. So what we're gonna do is, I think this one's already top, right? Yeah, that one's already top. And now this, and now that. Disable that. I don't want to see this. And then we have that. We can actually copy all these down. For the sorting process, we have to use the big circle, because if you can see here, the big circle is what define where both helices are at the bottom. So we don't we don't need that because we don't need any culling. So we can just actually, I'm almost there to say we can actually stop right here. So let's copy that bit part. Oh, it's gonna take a while. Oh, hope it doesn't crash. Okay, so the C is our curve. The P should be the planes that they where they with the frames that we defined at the beginning. I wonder why that takes so long though. Okay, now we have that. So we have all the points that interconnect. We trimmed it down. We remove any duplicate point using a component from Kangaroo 2. Just to remind you, I mean, at this point, I believe everyone should have a specific add-on installed by default, and Kangaroo 2 or both 1 and 2 should be one of those. If we enable that, and hey, what do you know? We have all our bottom support. One thing is we need to get rid of the top ones, and I believe we've done this part here, which I should have copied along with it. Oh, we need to explode it first, obviously. So that's what this part was for. We exploded it. Oh wait, not before, after polyline, and then we can do that. Can get that away. This import. Now what you see is we're actually not getting the results we want. Actually, we're not getting any results if you look at the output of the L. That's because in the sorting process, we are using, and copy that right here, we are using this formula. And what this formula says is based on the approximation of the of all these curves, right? Actually, the points, the middle points of those curves, to the deck plane, which is the XY plane that's almost on just below the deck, I believe. And if that distance is lower than 0.01, I should actually set this back to meters. 0.01 meters, then it will be deleted. But the problem here is then you would think like, okay, but those are not going to be 10 centimeters because that's a lot more than 10 centimeters. So why is this not working? The problem with that is we actually we made a small mistake, and that mistake is not discovered until now because the way that the sorting process work. We've actually applied this sorting process for two separate occasions for two different reasons. Actually, if my computer would not crash, I can show you. For example, we use this. In the first instance, we use this in order to separate the bottom from the top. Because we know the bottom of the plane is always going to be a distance negative, right? But then we actually reuse this for separating the the same reason that we're going to use it now, for separating that small part here, the small line that's actually on our deck, to call those off. And we're actually using that same thing, and that happens to work because the distances that we have, oh boy, oh no, that's not good, because the distances that we have, they're all positive. So needless to say, positive numbers will work with our formula that we defined here. But what we actually should have done is not work with positive or negative number, but just work with an absolute number, because in terms of distance, how far an object is from another, you don't need to say it's negative or positive. You just need to say how far is it. Is it 1, 2 meters, 3 meters? And that's why this thing can still work, because our bridge just happens to be at a point where the distance is positive, or actually where the top half is positive, because it happens to sit on top of the plane. But this one won't work for the bottom half because that sits on the bottom of our plane, and everything that's at the bottom of a plane that's on the opposite on the opposite side of a plane's normal will be negative. So let me show you then. All these distances, all of them are actually positive. Well, except for this one, because it's so close to the plane that it just sits right on the other side of the positive spectrum. But it is very close to zero, as you can see here. But that shouldn't matter to us because that's actually the one we need to call. So the solution for this is the top plane will work nonetheless. Nevertheless, what we can do is actually copy this one here, and let's plug that in here. And what we need to do is actually absolute the x, make it into a positive number. So we can actually just say abs. Actually, I think it can still. Well, let's use lowercase. Just yeah. And once you've done that, and then I can take that off, you will see the top half is now called. What you can also do if you want to keep it like you want to keep your script as clean and stable as possible, you can actually use this, or you should be using this for this one also. So observe. So we have these, right? We have how many outputs are we expecting? 429. You plug that in there. You still have 429 because the logic is the same. We just need to identify the distances. I mean, you can keep it as it will still work because the plane where it looks out to, which is the same plane here, everything above it will be positive. It does not matter how or what. So either you can say like, okay, you know what, I will just keep this for the middle one, which is totally valid. In our case, will work as fine. But you can also just say, you know what, I want to keep using that one for all my other helix except for the bottom half. For the bottom half, I have a slightly modified version of that formula, which is also fine, which I think might, well, it depends actually. Depends on what you want. Both logic works 100%, and very solid, very stable. It's just the which method of which of these methods you feel the most comfortable with using. In the end, they're delivered the same. So now what we can do is plug that into our, and now we have everything. The support for the major, minor, and all the ones for the bottom half. Okay. Yep. So what needs to be done now is all the ones that is connecting from the minor to the major, or from the outer helix to the minor helix, to the inner helix. And what I'm gonna do is actually save that for the next video. I think the next video will also be the last part to this tutorial series, and what we're gonna do is finish up our connecting lines, and we can maybe start doing the balustrades for the glass balustrade for our deck, and that should probably be the last one of to complete a bridge like this. And then hopefully you can have fun with it and play with it or render it out, whatever you want to do with it. So I'll stop this video here, and in the next video will be the last one, and we will pick up everything else, or the rest what needs to be done, and complete this tutorial. See you in the next one.